Part C is to express sin theta, cos theta, and tan theta in terms of t. Part D is to solve a sin theta plus minus b cos theta equal to c, where t equal to tan theta over 2. So whenever you see question that says you need to use t, or it says by using t equal to tan x over 2 or t equal to tan theta over 2, this means that you need to use t-substitution. And for t-substitution, we will apply LARCA as well. So if you have t-substitution, you apply t-substitution first and then you apply LARCA. And for t-substitution, the hint is to always start with double angle of tan. Let's do example 11, question 1. Solve the equation 12 cos x minus 5 sin x equal to 13 for x between 0 degree and 360 degree if tan x over 2 is equal to t. If you can see t equal to something, therefore we need to use t substitution. So always start with double angle of tan. Here, I'm gonna use the unknown x because in our question we have the unknown x. If the question gives you theta, therefore we're gonna use tan 2 theta equal to 2 tan theta divided by 1 minus tan squared theta. So follow your question for the unknown. So this is the double angle. Look at all your angle and then divide all the angles by 2. And you'll get tan x equal to 2 tan x over 2 divided by 1 minus tan square x over 2. And we already know that tan x over 2 is t. Therefore, this will become t. And this one here will become t squared. So in the numerator, we'll get 2t. In the denominator, we'll get 1 minus t squared. So we will use this information in order to get our right angle triangle. So just draw any right angle triangle. But just to be safe, just draw it in the first quadrant like this. So note that for tan, it is always O divided by A. And here, our angle is x. So here the angle is x. And hence, this is the opposite, this is adjacent, and this is hypotenuse. You can see that O is 2t, and A is 1 minus t squared. And to find h, you will need to apply a square plus O square equal to h square, and then you'll find the answer. But there's no need for you to do that by yourself, just memorize h, which is 1 plus t squared. So now using O, A, and h, you can find what is sin x and cos x. Sin x is O divided by h, and cos x is A divided by h. So we will use tan x, sin x, and cos x, and then we are going to substitute this back into our question. So, for t substitution, all these steps are compulsory. Starting with double angle, change it to become half angle, and then draw your right angle triangle like this, and then find what is tan x, sin x, and cos x. So our question is 12 cos x minus 5 sin x equal to 13. Substitute cos x to become 1 minus t square over 1 plus t square, and sin x to become 2t over 1 plus t square. And now we just need to solve this equation. Eliminate the denominator by multiplying everything with 1 plus t squared. So we'll get negative 25t squared minus 10t minus 1 equal to 0. So try not to have a negative sign in front of a quadratic term. So multiply everything by negative 1. And we'll get 25t squared plus 10t plus 1 equal to 0. This is a quadratic form and hence you need to factorize completely. Using your calculator, you can see that there's only one answer, which is negative 1 over 5. So when you rearrange, you'll get 5t plus 1. And since it comes from the quadratic equation there, therefore it should have a squared sign outside the bracket. If you just write 5t plus 1 equal to 0 like this, from this quadratic equation, this is wrong because this is linear and this is quadratic and they are not the same. So it is compulsory for you to write this square here. Because if you expand 5t plus 1 square, you'll get 25t square plus 10t plus 1 back, and this shows that they are the same. Therefore, you can see that t is negative half. And don't forget the meaning of t. T is actually tan x over 2. And you can see that this is actually a linear form and hence we can apply Larka. Change x over 2 to become alpha as per usual. And for negative 1 over 5, it will become positive 1 over 5. So alpha is tan inverse 1 over 5. And the answer is 11.30993 degree. So just take 3 decimal places, which is 11.310 degree. R is for range. And we can see that x is between 0 and 360. But we only want x over 2. So divide everything by 2. From the linear form, you can see that tan is negative. And hence, it is in the second quadrant and the fourth quadrant. Label your alpha. Next, we will look at the answer. If you look at our linear form, the answer should be for x over 2. And note that x over 2 is between 0 degree and 180 degree only. So this is 0 degree. It goes up until positive 180 degree. So starting from 0, you go up until you reach the first one, which is this one. And this is 180 minus alpha. And the answer is 168.690. And if you continue, you reach the end, which is positive 180 degree. So what about this one here? Note that this one is not within our range. So there's no answer for this one here. So there's only one answer for x over 2. And to find x, we multiply everything here by 2. and you'll get x equal to 337.380 degree. So if you look at our question again, x is given in degree, and hence final answer should also be in degree. So this is the final answer of this question. So that's how you apply t-substitution for any question that use t equal to something. So just apply t-substitution, draw your right angle triangle, and then apply your larka.